Broadcasting live from our studio in Boston with presentations from prominent industry vendors, Solutions Review presents Data Demo Day, an online event for data management and analytics.
I'm Doug Atkinson here at Solutions Review, and welcome to Data Demo Day. For this edition, we're presenting two of the most innovative data observability solutions available today. And this might well be the hottest data topic we're covering right now. As data teams build out ever more complex data stacks, they're also creating a greater need to monitor, detect, and investigate anomalies through a comprehensive data observability solution. So let's get into it. Up first is Monte Carlo. Monte Carlo created the data observability category around 3 years ago to help businesses eliminate data downtime. Just as we've seen in the application dev space with monitoring tools such as Datadog and New Relic, Monte Carlo is on a mission to bring the same level of automation and sophistication to data teams and data consumers. Monte Carlo's data observability platform is an end-to-end solution for your data stack that monitors and alerts for data issues across data warehouses, data lakes, ETL, and business intelligence. The platform uses machine learning to infer and learn your data, proactively identify data issues, assess its impact, and notify those who need to know. And to walk us through the platform is Ethan Post, sales engineer at Monte Carlo. Ethan, thanks for being with us.
Yeah, really appreciate you having us.
Well, it's great to see you. I'll ask you to give everybody just a quick overview of yourself before I kind of set expectations about how the next 25 minutes or so will go.
Yeah, so I think it's a fair question, and I think probably like everyone on the other end of this call, did not arrive at data observability, more by chance than anything, right? Having spent time as data analyst, data engineer, DBA, and other roles within data, I think there's a natural fit between folks that understand data and the challenges that data brings, and myself actually now getting the opportunity to sell a solution that actually automates for a lot of those challenges that people typically face. So that's why I'm so excited to have joined the team, and even more excited to have the opportunity to show some folks what we've been working on.
Well, as I mentioned in the intro, I think this is the most requested demo topic that we've had. Clearly, I think this is incredibly important to get to understand. I know you're going to walk through a demo and maybe a few slides in advance. I'll set everybody's expectations that if you have any questions, we'll happily take those in during Ethan's presentation, and I will then walk through those with Ethan at the end of his presentation in about 20 minutes or so. Other than that, Ethan, I'm going to turn it over to you and let you start to walk through the presentation you have, and I'll catch up to you in 20 minutes or so.
Sure, that sounds great. And first off, love the commentary around interest in data observability, and I think it's part of a broader interest in some of these industries that have spun up recently in relation to just increased spend and investments in data technology, right? So part of what I want to talk through today is how Monte Carlo fits within that architecture and how folks are looking at data observability. But one of the really nice things here, and I will show a couple slides, obviously my main goal here is to get to the platform as soon as possible. Part of the reason why I think people have such a vested interest or are so, they're chomping at the bit to learn about data observability is we're solving for a problem that folks have been aware of for a really long time, right? So what I'm showing here is essentially Monte Carlo's value proposition or the challenges that we solve. And if you think about the world of data quality and data testing, reality is that folks have been in the mindset of solving for data quality for quite a bit, right? And historically speaking, the way that this is typically done is through custom tests, writing things like custom SQL, working with the business to understand what should happen, and then trying to script that out, right? Unfortunately, what this leads to is a set of unpredictable incidents, or what we'll call the unknown unknowns of the world, in which machine learning is essentially the idea of allowing me to essentially plan for these unknown unknowns, providing things like freshness, volume, schema, things that are more predictable and can be leveraged in more modern technology. And then even looking at things like data quality, data distribution, and understanding how a tool like Monte Carlo off the shelf can solve for a lot of the kind of unpredictable nature of historical data testing, right? And then Monte Carlo, we also incorporate this ability to solve for what's more predictable, right? So building custom rules and tests within the platform. And what I'll talk through here, like the three levels of data quality and data observability. But the idea is Monte Carlo is going to do away with a lot of like the troubles of kind of that manual data quality testing and allow you to be much more streamlined and efficient as it relates to scaling data quality and data observability across your stack. The last thing I'll call out here is the intent here is really to be end-to-end, right? So Monte Carlo will be deployed on a modern cloud architecture, but many folks obviously are moving to architectures consisting of a data lake, a warehouse, right? Orchestration tools and BI tools. And the idea here is we want to go as far upstream as that technology allows us to go, right? This could be S3, this could be Databricks. But what we really want to do is capture as much tables and as much information as we can out of the box and automate for a lot of the things that normally have to be scripted out and more or less kind of guessed at. But then the idea is that the real, I'd say the pillars of the value proposition of Monte Carlo especially is, well, how do we help you detect things before your end users are the ones reporting them to you? How do we help you resolve them with minimal effort and in the highest amount of efficiency as possible? And then in the long term, how do we help you prevent data outages or data downtime, right? And then we're going to talk through a little bit about notification channels and how we operationalize Monte Carlo. But hopefully that's at least a good enough precursor to the problem that we're solving and the types of challenges that we see, day in and day out. So let's kind of talk about what I'm considering the three levels of data observability and the types of things that we'll typically check for. So when you think about Monte Carlo, I'd say a good comparison is more of that, I'd say like traditional manual data quality tests and checks. And what I'll call out here is, in this case, we might be connected to a modern cloud data stack that consists of like 2,600 tables. So 2,600 tables, I'd say, is a nice sweet spot for folks who have invested in their infrastructure, they have active users, and they have data consumption. But at this scale, it's very, very difficult to write manual tests and checks in a way that actually solves for data quality overall, right? What you get is kind of a spattering of checks and tests here and there, but there's never going to be any true sense of baseline data quality and data health for various parts of the organization, right? So here's where Monte Carlo comes in, right? I'm going to say, well, these 2,600 tables, imagine if I have to write 5 to 10 manual checks for each and every one of these. We very quickly get into the, hundreds of thousands, even sometimes millions of checks that are required for an army of engineers to provide full coverage. And what Monte Carlo is going to do is out of the box, connect to your infrastructure and start collecting metadata that helps us basically check across three main pillars. So freshness, volume, and schema. Essentially what we're looking at is for a particular table, how often are we updating or inserting records here, right? And as that happens, as we're inserting those records or as we're making changes to a particular table, how much volume can we expect, right? Are we deleting records? How many records are we adding? How often is this happening? And then finally, the silent killer of all data pipelines, right? Schema changes, meaning have I added fields? Have I removed fields? Have I done things like maybe changing a field type? And what we're doing here is we're automating this process of data quality and data health across the pipeline. So for a particular table, we're leveraging machine learning to understand what should happen and then alert folks to when those conditions aren't met, right? So compare this again to writing something like a freshness check that says, well, the business says this data should be coming every hour or every 2 hours. And maybe that happens, maybe it doesn't. But the real thing to keep in mind is how do we support these in scale when those thresholds are changing or when we're dynamically building on data pipelines, right? So you might look at this and say, hey, that's great. I have data quality and data health for my pipelines in terms of freshness, volume, and schema. But then we take it one level deeper, right? So what we consider custom monitors, a great example here would be something like a field health monitor, right? So historically, folks might be writing tests for things like uniqueness or null rates, right? We want to make sure that in a primary key, we have no nulls. What Monte Carlo is going to do is say, hey, look, we're going to take the same kind of machine learning based automation approach as we did up here in these automated monitors. And we're going to try to solve for some of those very common kind of scenarios within data quality. So here I'll look at actually a live field health monitor that we put in place and describe how this works to help cut down on some of those manual tests that need to be built. And in reality, say I basically flipped a switch and turned this on for maybe invoice data that's coming from our invoice application, right? In this way, I might have a field like my ID, for instance. And we'll actually be talking through this in a minute here, but essentially my ID should never be null, right? If I have an ID in a particular table, it should be non-null, right? It should be unique. So these are just some characteristics of data and of ID fields. Come to find out, hey, there actually was a massive dip in uniqueness in this ID field that happened last night, which is a scenario we'll be walking through. But past that, Monte Carlo is going to automate for things like %0, %, the types of checks that typically happen, but backed by machine learning to ensure that we know that this is an anomaly, right? But no one's had to go in and explicitly say, hey, this table needs to always be unique. And if it drops beneath a certain threshold, let us know. I'd say past that, the one area that we focus on, in addition to things like the health of your pipelines, the actual quality of the data that's flowing through those pipelines. Another view that I can give you here is more of what we call like user-defined monitors. So this would be, maybe I want to write custom SQL rules, right? There's specific business logic that I want to check for, maybe some kind of calculated metric or maybe some kind of join condition. And I have the ability to write custom SQL, be very explicit about these checks, or even define rules as they relate to things like freshness, volume, the ingestion of data, even oftentimes from things like third-party applications. So across those three levels, we're talking about automated monitoring for the data pipelines, automated monitoring that's basically the flip of a switch for things like the quality of your data, and then very specific, very configurable checks for the health of your business logic, the health of some of those join conditions. And across all that, what we're saying is, look, we have coverage for essentially everything that could break. Now, the next question that typically gets asked is, well, how is this operationalized, right? It's great that you're purporting some machine learning-based solution that can, solve all ails. It means nothing unless we can get data in the hands of end users and let them know when things look anomalous, right? So one of the great things I'll call out here is, normally I would flip over and I would show a Slack message or a notification that indicates a particular condition. For today, I actually kind of wanted to mix things up and talk about how Monte Carlo fits in this broader data ecosystem. More and more customers that we talk to have already stood up a data catalog, already have a bit of manual testing that's being done internally. So one of the things that Monte Carlo does is said, look, we're basically going to adhere to the way that you're hoping to get this information out to the public, right? Whether this is technical teams who are going to use PagerDuty or Slack to actually go in and triage incidents, or maybe more business-focused teams that might use something like Elation or additional cataloging tools. And if I'm an end user that says, well, I want to build maybe some kind of report based on invoice data, right? I can leverage my data catalog to come in and understand what's in this invoice table, what am I using this for, and potentially getting a better understanding of some context here. What Monte Carlo is doing is saying, look, we're identifying incidents, we're monitoring very broadly. One thing we can do is actually alert end users to the fact that a data quality incident exists, right? So I've set up an alert route, in this case to Elation, as an example of, we can integrate with those investments in other data governance and data infrastructure to help get that information in front of users that can go use it, right? I would say, just to kind of compare and contrast a tool like Elation to what Monte Carlo is doing is, here you'll see not only can we indicate warnings or indicate data quality flags coming from Monte Carlo, I can also link out to a Monte Carlo specific page for this particular table, right? And that traditional data catalog is really invested in surfacing context and surfacing all the things that an end user would need to leverage data. Monte Carlo is going to look at this table very, very differently, right? So here I'm going to surface results on things like freshness, volume, lineage. And the whole idea is, I want to understand what should normally happen in this table, and where things look anomalous, I want to basically surface that, right? So at the end of the day, I can look at things like, well, what does volume look like when we're adding records to a table, right? And I can get a very explicit view of that. The other thing that Monte Carlo is very focused on is this idea of helping technical teams or folks who are responsible for data quality understand what those key assets and pipelines are, right? So one kind of subtle indicator you'll see up here is this gold star. This is an indicator that Monte Carlo has identified this raw invoice table as a key asset, right? So the importance of a key asset to data quality is, if this table breaks, a lot of things downstream are going to break, and a lot of end users that are leveraging invoice data are going to be left wondering what's going on, right? So we're surfacing this idea of not only general information on a particular table, meaning, hey, this table is a 0.85 out of 1, right? It's super important. It gets used a ton. But we're also surfacing things like past incidents. So myself, as maybe a data engineer, now gets visibility into how often this high profile, high importance table tends to break, and what I need to do to then potentially go fix problems that we see with pipelines, or bolster some of the processes behind this key table. Because as you can see, right, we have a number of anomalies via field health, volume anomalies. We have some dimension anomalies as well. And even dating back to June, you're going to have to cycle through, a page or two in order to see all the times that this data has broken. Now, the general idea here is Monte Carlo is not only going to give you visibility into like a table level view, what we're also going to do is actually surface some incidents as these things are coming, right? So in this case, I can thumb over to my incidents tab, or actually I might leverage this Slack alert to say, look, this invoice table that I've been looking at here for the past several minutes, last night saw a massive addition of records to a table that we normally don't see this happen to, right? So 5,300 records added to a table where we're normally seeing like 1,600 records. And what I want to do as a technical resource or someone who's responsible for triaging this incident is just get a better understanding of what happened. So here's where we move from broad observability, broad coverage, and integration with your data stack to very specifically, how do we detect incidents? How do we resolve those incidents before an end user even potentially knows it happened? And then again, this idea of data downtime prevention overall. So as I dive into this incident, right, what we've already identified is we added 5,000 records to this table. And normally, as you see kind of volume increase here, we're only adding like 2,000 records at a time, right? So this is clearly anomalous, right? Even looking at this behavior, it's obvious that something's happening here that was unexpected. And now the question that you have to ask yourself is, just because the data broke, does that mean that I need to go fix something? Does that mean that I need to employ my expensive engineering resources to go put out a fire or go fix a problem? And because we've also brought in lineage, right? So we're pulling in query history, we understand how this data is being leveraged. We can even high level surface this at what we call an impact radius, right? So here we're saying, well, it's a single table and it's only queried like 82 times a week, right? So 10 times a day, somebody's reading from this table, or I have a process that's potentially loading downstream tables. But we also have integrations with tools like Tableau or Power BI or Looker or any number of BI tools. And what I can say is, even though this table is only being, say, read from 82 times a week, it's actually being used downstream in something like 35 dashboards, right? So as I expand this out, we can see a Power BI report here called Invoice Details Rolling 7 Days, or a Tableau workbook called Month-to-Date Sales Executive Snapshot. And the general concept is, not only can we identify that something broke, but we can also go in here and identify what might be broken as a result, right? So if I have a report that's called Month-to-Date Executive Snapshot, I'm going to assume that I have some folks in high places that are leveraging this data to make critical decisions. So I then have the ability to come in and, without doing a ton of digging, say, look, this is a Sev0 issue. I know it's hitting a number of reports. I know there are a number of affected users. This is something we need to go fix, or at least figure out what happened, right? So from here, we can set severity, we can assign ownership. Maybe in this case, I'll just assign it to myself since I'm working it. The general idea is, we can leverage Monte Carlo as kind of a service management platform, or similarly to how I showed Slack or Elation or any number of tools, you can integrate with a service management tool and triage this incident in your normal flow of operations, kind of the way that you live and breathe. Okay, so that's a lot about Monte Carlo as a smoke detector. How can we surface key insights or relevant information to determine not only what happened, but should I care and what should I do next? So the next question you might ask yourself is, okay, well, how can I determine what actually happened to go fix whatever may have broken? And there's a couple tools we have in place here. So here we would have integration with tools like dbt or Airflow or other orchestration or transformation tools. In this case, this table isn't being loaded by any of those, right? And in fact, what we can see is, because we're pulling in query logs from the warehouse that we're connected to, we can see exactly what happens here, right? So as records are being loaded to this table, say every several hours when we issue a query against this table to update, here's essentially what we're doing, right? We're copying data into this table from S3, pulling in a file and loading it to this table. Easy enough. One of the things that Monte Carlo will also surface is, because we're pulling in query logs, we can tell you, for instance, in this example that, hey, there was a query change detected, right? There's this bright purple bar up here that indicates that there was something run against this table to load in data that's not normally done. And if I click on this, it's kind of interesting. Some user has actually just ran a random insert into this table, right? So this is one thing that I might want to be familiar with, just to understand what's kind of happening outside of the normal processing of this table. And I even have some ability here to say, well, look, I just kind of want to compare what's happening between these two queries and understand what's different, right? Obviously, there's a massive difference here in that one of these is basically inserting a single record and one's inserting from a file. But it's important for me to just get familiarity with what normally happens here and what may have happened at the time of this incident. So I might be able to pinpoint this and say, oh, this is actually the source of this data problem. Turns out that's probably not the case. It might be related, but it's probably not the root cause, right? Another thing we can point to is just lineage, right? So in addition to understanding where the data comes from, as I've already kind of talked through, I might want to know also what the impact is downstream. So here's my invoice table. And if I increase kind of the scope of incidents on this table, I can look all the way down to essentially the BI layer, right? And what I want to know is when data breaks on this underlying or this parent table, what could essentially break downstream? And actually, we'll have visibility into data incidents overlaid on lineage all the way downstream, right? So we know the data is broken in this raw table. We can probably assume that it's also going to happen in staging and downstream, but it hasn't quite happened yet, right? So I'm at a point where I can fix this incident or figure out what happened before end users are actually going in and consuming bad data. So that's a little bit about what happened, what I can do to go fix things. Now, the last thing I'll actually call out is in terms of past incidents, not only at this time are we surfacing this idea of a volume anomaly, but we're actually also surfacing, excuse me, let me navigate here back to kind of my main catalog view. Because the other thing that I would call out is in this case, not only do we see a volume anomaly, we also see a problem with the actual data itself, right? So keep in mind, we added like 5,000 records to a table that we normally add, say between like 1,000 to 2,000 records. What we're also indicating is at the same time where we see this spike in volume, we're also seeing some anomalies in terms of the uniqueness of some of these fields, right? So we talked through this earlier in that example of field health that I gave. Notice that there's a dip here on things like subscription ID or my ID field. And historically, we're 100% unique on this field, right? It's a perfect primary key. It actually acts as a unique identifier of a record. All of a sudden, when I introduced all these records, I see this dip down to like 78%, right? So this is an indication that I have some anomalous data coming through, or excuse me, I have some duplicate data coming through that is likely the cause or the source of that influx in records, right? So Monte Carlo is not only identifying that, hey, we have an increase in volume, we should go look at this. We're also indicating the actual quality of the data. And keep in mind, this is all machine learning driven, right? So the fact that I can kind of correlate these two incidents and say, look, an increase in records is correlated with non-uniqueness in a field. Super simple for me to leverage a single tool to exactly identify what's going on here. Some additional tools we can look for to identify what actually is happening here is, well, I can also look at things like field level lineage. So I know I talked about table level lineage earlier, but I can look at this ID field in my invoice table and identify where it's being used, right? So when these field health incidents start to bubble up, it's enough for me to say, look, this table is being leveraged pretty heavily downstream, but it turns out the field in question is actually not that highly used, right? In this case, we're actually seeing that my ID field is obviously flowing through to my staging table, which is then being used in a number of facts and dimensions. So it turns out that having non-uniqueness here very likely is going to negatively impact things downstream. And I can kind of continue to follow this flow downstream into things like Tableau workbooks. Here's a looker view, right? So my ability to not only surface table level lineage, but field level lineage is super key in my ability to determine who's being impacted, what's actually happened, and what do I need to go fix. So moral of the story in this case is I've identified a massive spike in records for a table that I know is super important. I've also identified non-uniqueness indicating that there's duplicate records. So what I would do is I would actually go out to my application team, probably reassign this ticket to maybe a subject matter expert that actually owns Zora and say, look, for whatever reason, you're processing duplicate data that's then flowing to the warehouse. But in the meantime, I can at least drop some of those duplicate records, or maybe I can kind of pivot the data or partition and make sure that I can maintain essentially a clone of this table, but I'm not persisting bad data downstream, right? And that's the end goal here is detection is one thing, resolution and fixing bad data before it flows through the rest of my pipeline is probably the biggest thing. And then the final piece here that I'll call out before we get to maybe hopefully some Q&A is how does all this come together, right? Because I'd say very tactically speaking, hopefully there's great indication that Monte Carlo would provide value for like an individual data engineer or someone who needs to be on top of data incidents. But from a high level, the next thing that we strive to do is help organizations identify overall data health and data quality. So here we have, an in-platform data reliability dashboard that helps me understand, hey, across the board, I have like a 98% freshness rate, right? 98% volume rate as it relates to uptime. Now you might look at these and say, those are pretty good metrics, but normally what we're doing is we're driving this understanding of the baseline health of data and helping organizations increase that quality over time. I'd say a side benefit of this is also adhering to like SLAs with the business. So if I'm able to say, look, we're going to adhere to 3 nines worth of reliability here, obviously we're far away from that, right? So it's our ability to not only define some of those SLAs, but hold ourselves accountable and prevent data downtime and increase data quality over time. Now, the last thing I'll talk to before we kind of end the demo portion of this conversation is we also really align with the way that organizations are have structured themselves for data, right? So in this case, I've defined a number of domains here, and I can look at not only from a population perspective, but also billing and payments, for example. Well, billing and payments outside of those 2,600 tables in our total population, it's only like 21 tables that might come from multiple applications. And if I look at this specifically, 108 incidents across these 21 tables in the past 6 months, from a rate perspective, that's astronomical, right? And the other thing I can look at is things like status update rate or time to response or time to fixed, right? And the idea here is I can actually map my ability to triage and effectively respond to incidents in a way that's kind of striated by the way that you organize the business. Now, the value here is not only can we give you a tool to respond to and fix poor data quality, but we can actually hold organizations accountable to the data assets that they own or data stewards who have accountability to the business. So hopefully that resonates with the way that folks are thinking about data quality and data downtime. Obviously, for more information, we're happy to schedule one-off follow-ups. But Doug, I'll turn it back to you. Hopefully there's some questions that have come in that we can kind of talk through here.
Yeah, great presentation, Ethan. There are a couple of questions, probably some that you've gotten in the past, but certainly one of them is, what is the path that someone would take to kind of begin a consideration cycle for a solution like this? How does it typically go? I mean, you're probably on that team.
Yeah.
When, where do they come in? How long does it take? What are the kind of dance steps that get them into a kind of a proof of concept, I guess?
Yeah, it's a good question. So as a sales engineer, I have the ability at Monte Carlo here to speak to, dozens and dozens of cases of folks having interest in data observability. I would say some of the main prerequisites here are an investment in a modern cloud data stack and data and pipelines that are actively populating, right? So a lot of organizations would say, hey, look, we're looking to move to a new warehouse. We want to get a solution in place proactively. And I would say at that stage, I think it's fair enough to start exploring options. But where you're going to really see the value of Monte Carlo is on, up and running pipelines and things that are actually being populated. So that's probably step number one. I would say another indication that folks are ready to explore a data observability tool is the fact that you might have like some spattering of manual testing or some of those things that I talked about early on, indicating that like there is a problem, there's something that we're trying to go solve, and there might be this recognition of we can't do this at scale, right? We can't rely on one person to go write a bunch of SQL tests to capture this. And I think that's where turning to an off-the-shelf solution is probably a good option.
And who in the organization would you typically see engaging on this solution? I mean, where are you finding traction with folks?
Yeah, I would say typically the folks that we start working with are going to be more of the technical team, right? The folks who are actually like dependent, or they're actually they are beholden to high data quality. So this would be data engineers, data engineering managers, folks who actually sit in the data organization. And then as we branch out and we go through things like a POC, we actually start to pull in folks in the business, right? So, oh, hey, this leader from sales has 2 or 3 key metrics that they want to make sure are of high quality. How do we adhere to that? And how do we make sure that the tool that we're evaluating can actually capture and satisfy those requirements? So I think it's a fair question.
And ultimately, last bit here, what advice would you offer to somebody who's thinking about considering a data observability solution? What should they be thinking about?
Yeah, we hear it all the time, right? And there's this idea of like Monte Carlo's focus on automation gives this impression that it's a silver bullet, you plug it in, and all of a sudden we have perfect data pipelines, right? Just like any other technology investment, there's going to be a people element. So how do we align our people in a way that puts them, positions them for success? but there's also a process, right? How do we go from a crawl, walk, run? And the intention of Monte Carlo is to make that process very, very smooth and quick. But I'd say that there is, there is change management that's involved here, and the ability to internalize things like getting new alerts and understanding how to use the tool. So I would say a focus on not just the technology, but how do we set ourselves up to use it effectively?
Yeah, great. Well, thanks very much for the presentation. Best of luck in the coming year, and we'll look forward to seeing you soon.
Yeah, I appreciate it. Take care, Doug. Thanks for having us.
You bet. Moving along now on this tour of two of the most innovative data observability solutions available today. We're going to take a look at Telmai. The Telmai data observability platform is designed to monitor data at any step of the pipeline across both structured and semi-structured systems to reduce the time spent on detecting and resolving data quality issues. In this demo and QA session, you'll see how Telmai solves data quality problems by automatically learning from your data and detecting unexpected values, anomalies, and drifts in your data in just minutes. A couple of key points to notice about Telmai is that Telmai uses machine learning to scan data sets, detect freshness, and completeness for each. Telmai is able to measure the accuracy of data by looking at actual data values in addition to metadata. And to walk us through the Telmai platform is Max Lukichev, CTO and co-founder at Telmai. Max, thanks for being with us.
Hi, thanks for inviting. I'm glad to be here.
Well, we're thrilled to have you, and we're always thrilled to have a co-founder and a CTO as well. Before you get started, I think Telmai has a really interesting backstory, and you're the perfect person to tell it. Give us a little bit of the path that you've taken to get to this point where you've built this data observability platform.
Yeah, so my background comes from computer science. For many years, I started actually as a computer scientist working back at HP Labs, and over time, the data problems caught my attention big time. And probably 15 years back, we started looking and seeing all these data quality issues which were affecting our machine learning work and such. And later, when my co-founder and I, Mona, we were working at Reltio, we saw it big time. How much of impact bad data does for like the master data management systems. It's just basically ruining the entire workload. Just injection of duplicates in the data can mess up your merging and matching logic. So later on, as I moved on my career, I also worked as director of engineering at Signal FX, the infrastructure monitoring system. And this idea came up. Okay, how about we solve the data problems that we saw back at Reltio, which had a huge impact, with some ideas and approaches that infrastructure monitoring adopted over years.
It's a really compelling solution. I'm really glad we're able to show it to our audience. I'm gonna set everybody's expectations that if you have any questions, shoot them in. We'll save a few minutes at the end to go over those with Max. But otherwise, Max, I'm going to turn it over to you. I know you're going to walk through a little bit more about the company and a demo of the solution. And then I'll see you in about 20 minutes or so, and we'll go through any questions that the audience has, and I'll have a few myself.
Awesome. Yeah, so to start with, what is Telmai? So Telmai is a data observability platform which helps you monitor your data anywhere in the pipeline, to the very left side of the pipeline or to the very end of the pipeline where it's close to the consumption. What it means is, yes, indeed, it's monitoring files, databases, data warehouses, even streams of data as the data still flows. Another thing is it's not only limited to monitoring the metadata, like the volume or uniqueness of the values or the schema itself. It's really designed to look deeper into the data. Is your data accurate? Are your values valid? Are there records in this table fresh? Looking deep into the data. And finally, it helps to operationalize it by providing rich REST integrations. You can augment your solutions which you already have in your data system, like your data catalogs, or orchestration of the pipelines, stopping, pausing, restarting your pipelines based on all the findings that Telmai gives you with its rich analytics capabilities. In this demo, I will walk you through the typical path that customers go through. We will start with connecting to the data. It can, as I said, it can connect to anything. It works with structured or semi-structured data. That means, analyzing deep JSON with nested and multi-valued attributes. Reads files, streams, whatever you throw at it. We will look at the deep profiling and investigation, looking for anomalies in the data, translating some of the findings into the expectations, or call it rules, for high impact attributes. Then going broad, when letting system to learn on the data. When you have a lot of attributes, you obviously cannot design rules for all of them. So we can let system learn through the data eventually, and see what's the expected format of the data, how the data should look like, what's the shape, and start generating anomalies fully automatically without any configuration. Making another step further for super critical attributes, which are key essential attributes for your business, even going to detect accuracy of the data. It may look valid, it may look fresh, but is it accurate? Is your sales number reflecting the reality? Looking at that level of complexity. And finally, we'll touch on the operationalization of your data workflows. That means augmenting your data catalogs, controlling your pipelines through REST, or simple as filing Jira tickets automatically. In this demo, I will be using a data set called Open Payments. For those who are not familiar, Open Payments is something you can download and access from the CMS website. It's about interactions between pharma companies and doctors or healthcare providers, HCPs, to see how they're paying them in forms of different conferences, presents, and such. So just to make all this transparent and available for the general public. This is a great data set for doing demos, by the way. So if you like, you can get this idea and use it for yourself. So in this data set, there are two most interesting tables. One is HCPs, doctors, and the one is payments, transactions. As you may notice, we also, like I mentioned, we can process JSON data, semi-structured data. The benefit of Telmai, it can do it at any scale and without any impact on the performance. In fact, one of our customers had a table in Snowflake with a JSON field, which when unwrapped had 8,000 attributes, all nested, multi-valued, very interesting schema, and Telmai was able to handle it just well because of the interesting approach that we take scanning this data. We don't flatten, we actually look at it as a stream. To mention here is the journey starts with connecting to the data. There are different integrations we provide out of the box, and if something is not on this list, we can very quickly build this integration because our integrations are super lightweight. It's about just a few days to throw in APIs because all the analysis happens outside in Spark. As I mentioned, streaming is also a possibility. If you have Kafka streams or pops up, GCP pops up, yeah, we can do that too. So once you connect to the data, we will navigate to the first step, looking at the profile of the data. So we analyze this data set fully. There's no blind spots. We don't have to do sampling. It's a very efficient process. So what we found is there was 1 million records. Completeness overall was 80%. Correctness was 99%. I will talk a little bit more about correctness and freshness just in the next step. But here we see that for every attribute, we extracted the profiling information. What's completeness for that attribute? What's the number of duplicates, unique values, distinct, and so on. Typical for profiling. It's all interactive, so you can really narrow down to stuff that you really care about. So say I want to only look at a few attributes which are critical for my business. What are the measures? What are the key metrics for them? Do just like that. And also, it is all historical, so you can see in the perspective of how this was changing against yesterday, the day before, and so on. But if you're really interested in your data, in terms of what are the anomalies in my data, is it all good? You can really look deeper. You can go to the investigator component and let it load a little bit. So I will show the zip code attribute, which might be important for my reporting. You can see if my data is actually valid here. So what we see here, there are patterns that we extracted from the data. What this means is there are two main patterns of the zip code: digits, hyphen digits, or just digits. So I can click on each of them and see what the values are. But then we notice that Telmai detected a bunch of garbage there. And this is actual data, right? So I can look at the anomalies based on the lengths, and look, all this garbage was in the actual CMS data exposed, right? So these are not valid data. So I might decide, okay, zip code is so important for me, I might just go and set up an expectation, just like you would do in other open source tools. But here it's all visual, no code needed. I can say, I want to accept only patterns of digits and digit hyphen digit, lengths between 5 and 11, done. So next time when we analyze the data, the values which were did not meet these expectations, they would be considered incorrect. And that's why they would the correctness will not be 100%. Let me switch to a different date. Like in this case, correctness on that upload was not 100%. There was about 1% of garbage data in the zip codes, which, actually 10%, which I see here in this number. Very similar with freshness. Freshness is it's my favorite topic, to be honest. One interpretation of freshness is, how frequently you update the table, which is good. It monitors if your pipeline are working fine, you're regularly updating, writing data to your table. But what if the data in your table is not 100% fresh? And in case of, in this particular case, for healthcare providers, we decided that if the doctor hasn't been updated within 3 months, this data is old. And that makes sense because doctors change their affiliations, they move to different zip codes, sometimes they change specialties, but this is actually another case when too many specialty changes would be considered also bad, right? That means the data is becoming not accurate. This is how you can do this. You can set an expectation that, I will consider my data fresh if the doctor or the record was updated within the last 3 months, based on the timestamp last record update date. And another point here is to make it more relevant to the user. This data often comes from different systems, from different databases, from different geographies. It may be different data about different hospitals and such. So Telmai can really look at this, at the kind of segment this data and look independently in the different segments. For example, I can see how my Texas data looks like, and this is it. It just suddenly changed, all the metrics changed. Or how is my California data? So you can really look deep into, where your problem is, from which segment of the data the noise is coming. So far, if you look at this journey, we discussed connecting to the data, analyzing data of any volume, no sampling needed, any schema, anything, files, databases, streams. We were able to set up some expectations and detect anomalies based on these expectations. But now the interesting part comes. Let's put this data in motion. So let's start scanning data regularly. Every day, every hour, doesn't matter. And let system learn how the data looks like so it can start making predictions. So for that, I will switch from the doctors to the transactions data, the payments, the actual interactions between doctors and pharma companies. And let's look at the trends. So here what we see is that on average, we were getting around 200,000 records. And at this time, we got 267, which was actually produced 4 kind of alerts, 4 kind of problems at that point. So one obviously was the spike in the record counts. So the blue sector you see here is what system predicted using machine learning, what was expected range of the data. And obviously we shot through this range, generated alert, having a problem. But why is that? So we can look at, okay, what's going on in the Texas? Everything is good. You know, there's no anomalies. Data was just as predicted, coming just right. But what about New Jersey? And we see here that problem. So we see that the record count shot up twice. Uniqueness went down from 100% to 0%, which pretty much means we got the exact duplication of the data here. And this is not only limited to simple metrics, you know, percent of unique values or completeness. It can be anything. It can be correctness based on your expectations. It can be these are different policies that we have. It can be schema drifts, freshness drifts. It can be drifts in the shape of data, in the distribution of the values in the data. All of this detected automatically. And this helps a lot with detecting if your data is fresh and valid, the values look normal. But is this data accurate? This is actually a very interesting question. Because one of our customers had this case. In the databases, they had more than 300,000 entities where there was a very important attribute, employee count, for each of them. And they wanted to see the drift for each of these 300,000 entities if the data is still accurate in the database. And that's what Telmai provides with the concept of business metrics. What you can set up is, it's a very similar concept to an aggregate query. What we are saying, let's look at the total amount of payments done by a company, by the payer name. So we are taking the sum over total amount of payments grouped by payer name. And we start tracking this across hundreds of thousands of companies in this database. And what we notice on the last upload, we have a drift. So this metric, total amount of payments, drifted in 2 companies. So I can click on that and I see that Genentech went from a range between 8 to 11 million, which was historical trend, down to 0. So they paid $0 during kind of this period for which we analyze the data, which definitely is an anomaly. At the same time, Allergan went up from about 6 million average to 15 million, right? Again, tells me a story. Correlation of those 2 facts, probably I got a mix-up of data somewhere. Maybe transactions from Allergan, from my Genentech being recorded as Allergan or something like that. So the point here is, with the tool like that, you can very quickly determine, is it an actual data quality problem? Is it your pipeline giving you the wrong data, or it's your business problem? And based on that, you can very quickly decide, okay, who should be alerted? Is it just like an engineering team, or it has to be brought up? With that, we just covered the continuously monitoring part. The last part I wanted to show is the operationalization. All of the alerts that we generate, you can, for different kinds of, for different sets of attributes, for different type of policy, type of alert, you can be very granular who gets alerted on them. You can define your policy and set who gets notified, your data ops team, your sales ops, and the channel how you get it notified. Do you want to do Slack message, email, or maybe you want to automatically generate a Jira ticket and make an assignment? So this is one part of that. But what if you already have a lot in your data ecosystem and you want to, for example, augment your data catalog? in a second, I will open Postman. So Telmai can help with that too. So everything we saw here in the application is available through API. So overview page, investigator data with anomalies highlighted, trends, alerts, everything available through API. So you can really have a data catalog, which you already probably have some solution, and augment this data catalog with your data quality information, with examples of bad data and all the profiling metrics available. So really don't have to kind of reinvent the wheel and just combine things that are available to you already. Or on the other example, you have pipeline, and if, for example, you detect that your data is outdated, or there was another customer we worked with, they had a case where they wanted to detect exposure of PII data into the attribute, into the comment section. So they wanted to bring their own language model and to do analysis and detect that there is a certain amount of records having this PI data exposed. That means full stop on the pipelines. Just shut it down, because that may become a liability issue, right? So you can fully automate those type of scenarios with the analytics that Telmai provides you, with the deep description of anomalies and alerts that's being generated. So you can be very granular and accurate on how you react in an automatic way. Like in this case, what I'm showing, this alert generated for this source with this ID, and it says that the policy that was violated was freshness, last record update date, up-to-date record validity was only 98.5%, right? So you can make a control in your Airflow or anywhere to decide like what you do with your pipeline. Stop, restart, alert, anything like that. With that, I'm wrapping up my demo and passing it back to you.
Well, thanks very much. Outstanding presentation there. Certainly have a couple of questions. How does Telmai track data quality on semi-structured sources?
Yeah, this is one of our strong sides. We can monitor anything, anywhere. So this whole idea started with the fact, again, back from Reltio days, we were bringing data from anywhere. And the biggest problem was once you bring the data, it's too late. Like you already crashed your system if it's garbage. So we started from the fact, okay, let's monitor anything, files, streams, databases. And one component there was this data comes as JSON. Oftentimes it's either Parquet, Avro, or JSON. And pretty much every customer we work with, they have those very critical attributes, which are nested attributes, semi-structured data. Telmai has a very interesting approach monitoring this data, which makes it so efficient. Very classical way is you would go and flatten these attributes. But that creates a problem if you have those arrays in those nested attributes. It's just going to lead to the cross product and exponential expansion of the data. It will kill any system. And if you monitor hundreds of attributes or thousands of attributes, it's definitely not going to work. So the way we do it is our analytic engine. In Spark, we have the special algorithm how to look at this JSON, looking at it as a stream, so we can really leverage, horizontal compute across all of the attributes at the same time.
Another follow-on that we've received is someone who's built data quality rules to check the validity of their data, but their issues can be isolated to a particular segment of data. Mm-hmm. How does Telmai handle that?
Another great question. The fun thing is, if you look at the real data warehouse at a decent sized company, this data, even though it's sitting in the same table, it's pretty much coming from different source system. It has different quality depending on the segment of the data itself. And the rules which have to be applied to these segments are different. So some segments, some sources are so important, and there is certain validation of, let's say, zip code should be applied. But the others, it's like, yeah, we probably don't even have data from that source populating this attribute, so we don't need to have a rule there. And Telmai can support that. Our rules are applied very granularly, so you can define which segments you want to have and really be targeted. Like here I will apply one rule, here I will apply another rule set, and so on. So Telmai can analyze this data independently between these two, between these segments, even in the same table.
This is why it's important for us to have the CTO on this demo. You're knocking these out. Another one. We have Snowflake as our analytical system, and we have to consider not overloading that with queries to validate the data. Does Telmai run queries on our system? How often, etc.?
I want to admit one thing. Many years ago, I made a very expensive mistake. I tried to build the data monitoring system by running a lot of SQL queries to the data. And I learned my lesson and I decided not to do it again. So that's why when building Telmai, the approach we took is get the data into the Spark instead of loading your underlying Snowflake or BigQuery or whatever it is. Because just the query, the proper monitoring of data and extracting dozens of metrics per attribute generates tremendous amount of queries, tremendous amount of load on your underlying data warehouse. It drives up costs insanely. It is bad in performance because that part does not scale. The query scheduling does not scale that well. So that's why Telmai, once it runs very cheap query to the data warehouse, extract the data, and then does all the heavy analytics outside. So you can control you have much better control of the cost of how often you run the queries, like without surprise bills from the underlying systems that you're monitoring.
Excellent, excellent. So let's get into getting engaged with Telmai. So I'm somebody who's watched your demonstration. I'm intrigued. What's the best way to start to consider Telmai? Is there kind of a path that you typically take somebody that's interested in exploring the Telmai solution?
It's actually very simple. You can go just to our website, telm.ai, go to sign up, get the free account. You will get in just a matter of minutes free access to the platform. You can play with that. Ask any questions you need. Ask for help if you need any help. We are glad to help. We are always available. And yeah, just play with it. See if it's for you, if it's helping you.
Max, I think you've done a wonderful job. You certainly answered everybody's questions. Made a nice presentation. You clearly have developed this with lots of experience behind it. Nicely done. Best of luck in the coming year, and we look forward to reporting more on Telmai as we go forward as well. Thanks.
Thank you so much. Thank you.
You bet. Well, there you have it. Another data demo day in the books. We want to thank both companies for their fine presentations, and we appreciate your attendance as well. Until next time, I'm Doug Atkinson here at Solutions Review. Thanks for watching.